Hello, this is going to be a video that's going over multi-step equations. This is a continuation of last lesson. So when starting with a problem, such as this one on the screen, you'll notice we have a lot of operations that are going on. It looks like a large fraction. We also have plus 1 divided by 3 minus 4. So when you're solving this, the first thing that I would get rid of is probably the minus 4. And if you do that by adding 4 to both sides, and then once you're at this part, you can just multiply by the denominator, like we did earlier in this unit on the day of two-step. And then x plus 1 equals 14 times 3, which is 1242. And you subtract 1 from both sides, equals 41. And the way that you go about checking it is you can just substitute the 41 in. So you would do 41, let me see if I can do this on here. Sometimes highlighting on Desmos is a little tricky. 41 plus 1. It's like not going to let me do it. I'll just put parentheses around it. That way it knows to put it in the numerator. Divided by 3 minus 4, and there it is, 10. So you can check it to make sure that it works out. Okay, so now looking at one that's, actually we're going to skip that one and go down to one that has a lot going on. Now don't be intimidated. You could definitely do this. The reason why there's 2 arrows is because there's kind of 2 different kind of ways to go about this. The first way is just to deal with the fractions. Combine these two. They both have x's, so they're both like terms. And then multiply by their reciprocal. That's kind of the first way. The second way is fraction elimination, which is a little bit more advanced, but if you can know your multiplication by fractions, it can actually make your life a lot easier in a lot of these cases. So I'll do it first, just to combine like terms using the fractions. This is x over 3, but it's really just 1/3 x. So when we combine both of these, even though they're fractions, they both need to have x in it in order for you to combine. So if I'm combining both those terms, we're just going to, just like when you would subtract fractions together, this is really just 1/3 minus 2/3. As long as you have the same denominator, you go ahead and subtract those together, and you get negative 1. So it works the same way, but instead we get negative 1x, or just negative x is fine too. Equals 4/3. And then from there, you multiply by the reciprocal. Negative 3 over 1 on both sides. We end up with x equals, that's negative 12 divided by 3, or negative 4. So that's kind of the first way. You can just deal with the fractions and combine them up. The second way is by getting rid of the fractions. If the initial step. So all of these numbers have the same denominator, which actually works out really well when you do it this way. Instead of trying to combine them, we can actually eliminate the denominator or turn the denominator into a 1 by multiplying by 3, or whatever the common denominator is. So if I multiply each term by 3 times, remember this is really 1/3, is 1, 2/3 times 3 is 2, 4/3 times 3 is 4. So I can just eliminate, this turns into 1x minus 2x equals 4. So if you're good with multiplying fractions by whole numbers, this is definitely the way you want to do it. Then if I put those 2 terms together, I get negative 1x equals 4, and x equals negative 4. So, like I said, 2 strategies. Let me see. I don't know if I want to do this one. That's kind of similar. Let's do like one that's a little bit more challenging. Oh. Now I'm like changing my mind again. Okay. Let's do this one. So same kind of thing. We could either just go ahead and combine these like terms. They both have fifths, so we don't need to find a common denominator. So you can add 2y plus 1y, which is 3y over 5, which, by the way, that's the same thing as 3/5 y. But it is not the same thing as 3 over 5y. Those are not the same. So 3/5 y equals 9/5, and then we can multiply by the reciprocal of 3/5, which is 5/3. So you end up getting y equals 45 over 15. You can also cross simplify here and here. So it's just y equals 3. So that's the first way. And then the second way, if you do the same problem, would be if you multiply everything by 5. So 5 times 2/5 is just 2y. 5 times 1/5, really y over 5, that would be just y. 9/5 times 5 is 9, and then you get 3y equals 9. And then y equals 3. And again, you can definitely check all these, right? So you can plug it in. We know it's 9, which is great. Let me actually go this way again. 2 times 3 divided by 5 plus 3 divided by 5. 1.8, which is 9/5. Boom, done. Okay. So let's see, the last one from here, they're all different denominators. You can still do the same kind of approach. However, this term here has an x, but the other one does not. So we're actually not going to combine those two because they both need x's. This is just a regular number, and this is a variable. So we're going to solve this like a two-step equation. We're going to first get rid of the 9/10, and then we're going to multiply by 15. I'm going to show you two ways for this as well. We'll do it the first way, just dealing with the fractions, and the second way, eliminating the denominator. So if I'm just dealing with the fractions, whenever you add or subtract, you have to have a common denominator. So the first thing I'm going to do is just subtract 9/10 from both sides. And that's just going to turn to 0. But when you do 4/5 minus 9/10, they both need to have the same denominator. So therefore, you have to multiply really by 2 over 2. And that's going to be 8 over 10 minus 9/10. So now we can subtract them. That's going to be negative 1/10 equals x over 15, what's left on the other side. And then from here, we're going to multiply by 15 on both sides. And that'll be negative 15 over 10. Or once you simplify it, you can divide both of them by 5. Negative 3/2, or negative 1 1/2. Alright, so you can eliminate on this one too. It's so sad when you erase all your work. It's a little disheartening, all that work. It's gone. Okay. So then the other way is kind of to do a fraction elimination. You have to multiply, and this one's a little trickier because all the denominators are different. You have to multiply by a common denominator of all of them. So 5, 10, and 15. So I can get them all to 30. That's probably where we're going, right? So I can multiply 10 by 3. I can multiply 5 by 6. I can multiply 15 by 2 to get to 30. So if I multiply everything by 30, 4/5 times 30. So that's what you want to do, 4/5. And you can just kind of work out the math up to the side. So 30 times 4/5 is going to give you 24. So that's going to turn into a 24. When we do 30 times 9/10, so 30 times 9/10, that's going to simplify to 3, so it'll be 27. And then this is 30 times 1/15. Essentially, we're just dividing 30 times 1 divided by 15. That's going to be 2. And then from here, you would go ahead and continue solving. So minus 27 from both sides, negative 3 equals 2x, divide everything by 2. So either way you want to do it, you're kind of doing fraction with both. It's just on for this one, you're kind of doing all the fraction stuff up front and solving without. And on the other one, you're not. Okay, hopefully that was helpful. Thank you so much for watching.